guys, welcome to another lecture from Introductory Statistics. Today we will work on a specific concept associated to the expected value, which we have been working on in previous couple of classes. Expected value of a random variable is something which is very clear to us. Sometimes what happens that you're not interested in the expected value of a particular random variable, but something associated to it. For example, what if I'm interested in finding out what is the expected value of x square, x cube, twice of x? So here comes the concept of expected value of a function of a random variable x. You can call it E, expected value of a function of the random variable x. Okay, let's understand this through an example. Suppose a bookstore purchases 10 copies of a book at $6 each to sell at $12, with the understanding that at the end of a 3-month period, any unsold copies can be redeemed for $2. If X is the number of copies sold, my first question to you guys, what will be the net revenue? Think about it. Pause and write it down wherever you are noting. Now, the net revenue depends on the number of copies that you've sold, right? So, net revenue, I can call it the function hx, where x is the number of copies that you've sold. You are selling for $12. So, that means you will be fetching a revenue of 12x. X is the number of copies that you have sold. In total, you have 10 copies. If you are selling X, that means you're not able to sell 10 minus X. Okay. So ultimately, it's given that after a 3-month period, you can redeem these copies for the ones which are not sold for $2, right? So that means my total revenue will be 12X from whatever I've sold. And after 3 months, $2 each from 10 minus x copies. Okay, so plus 2 times 10 minus x minus, of course, there was a cost attached, right? So the net revenue, the gross revenue is this. Now net revenue will be when you subtract the cost. We are purchasing 10 books for $6 each. So 60 has to be subtracted. This is your net revenue. Now, my question is, what is the expected net revenue? What do you expect this net revenue to be? In this question, the revenue is your function of the random variable x, and it turns out to be 12x plus 20 minus 2x minus 60. So that means it turns out to be 10x minus 40. This is the function of the random variable x. If I am supposed to find out what is the expected net revenue, then I should know something about this random variable x. If I know everything about this random variable x, I will be easily able to figure out what is the expected net revenue. In order to compute the expected net revenue, that is the expectation of net revenue, which means that I am interested in the expectation of the random variable, which is 10x minus 40. I'm not interested in the expected value of x, but rather 10x minus 40. Now, I know how to find out expected value for any random variable x, but for that, I need to have probabilities attached to various values that x is taking, right? So let's extend this example. In case I am given enough information about the random variable x, I can easily compute the expected value of 10x minus 40 as well. So suppose x is taking the following values. Suppose x, which is the number of copies sold, starts with 4. It takes value 6. It takes values 8. And suppose the probability attached to the value that x is taking. With 4, it is 0.5. With 3, it is 0.3. With 8, it is 0.2. As you can see, the total is definitely 1. Now, what I have to do is I have to find out the expected value of not x. I'm not interested in x. I'm interested in the expected value of a new random variable hx. Let's take it as random variable y. So if I take hx as some y, so I'm interested in the expected value of this random variable y. Now, what is y? Y is equal to 10x minus 40. So when x is 4, 6, 8, at the same time, y would turn out to be 10 multiplied by 4, that is 40, minus 40, 0. Here it would be 6 multiplied by 10, 60 minus 40, 20. Similarly, 80 minus 40, 40. Expected value of y, any random variable y, is summation y into py. So what do I require? I require the probability associated to this random variable y for various values that it is taking. Now the value of y is getting generated by the value of x, as you can see here, in a linear manner. Understand that if x is 4, y is 0. So the probability with which x is 4, with the same probability, y turns out to be 0. So therefore, py is nothing but 0.5, the same probability as the probability with which x is taking value 4. Similarly, 0.3 for 20 and 0.2 for 40. Okay. Now, this is your distribution or PMF for y. Once you have that, it's very easy to find out the expected value of y. This y is nothing but our hx, the net revenue. So net revenue turns out to be 0 into 0.5 plus 20 into 0.3 plus 40 into 0.2. That means it turns out to be plus 8 is what you get. That is 14. That is your net revenue, or as in profit. Okay. What have we done here? Specifically, just understand that what we did here was that expected value of function of x, which we took as y, expected value of y, was nothing but the summation of y py over all the y's, right? Over all the values that this random variable y is taking. Now, this random variable is nothing but hx. And did you observe what was the probability associated to every value of y that we took? It was same as the probability associated to x because this was generated out of x. So here I can just write down px over all the values of x because every value of y was generated using the value of x. So basically, expected value of a function of x is summation over all the x's, hx instead of just x, the function of x with the probability attached to it. The weight that you will attach to every value of this function will be same as the weight attached to every value of x. Formally speaking, if the random variable x has a set of possible values d and probability mass function px, then the expected value of any function hx denoted by expected value of hx or mu hx is computed by, for any discrete random variable, summation over all d, the entire domain, hx multiplied by px. It's the weighted average or your new random variable, which is the function of x, hx. The weight attached is exactly as the probabilities attached to the value that x is taking. Okay. Let me take you through another example. A computer store has purchased 3 computers of a certain type at $500 a piece. It will sell them for $1,000 a piece. The manufacturer has agreed to repurchase any computers still unsold after a specified period for $200 a piece. Let X denote the number of computers sold. Exactly similar kind of scenario that we had. In this case, additionally, let's suppose following are the probabilities associated to the value of X. Say X can take values 0, 1, 2, 3. It takes the value 0 with probability 0.1, 1 with probability 0.2, 2 with probability 0.3, and 3 with probability 0.4. Okay? So that's your Px. Further, let Hx denote the profit associated to selling X units, which means that Hx will be equal to revenue minus cost. What is the revenue? If he is selling X number of computers, so he is fetching 1,000 from each, so 1,000 times X plus if he is selling X. So since there are in total 3 computers, he is left with 3 minus X unsold. Unsold pieces go at $200. So he's fetching 200 from each unsold. So plus 200 into 3 minus X minus he has bought each computer for 500. So in total, he has spent 1500. Okay. So 1000x plus 600 minus 200 minus 1500 is what you get. That means 800x minus 900. Now, what shall we further find out? Let's find out the expected value of the net revenue or the profit, expected profit. Expected profit means expected value of Hx. So we are interested in finding out expected value of 800x minus 900. So x can take value 0, 1, 2, 3. Therefore, Hx simultaneous can take values minus 900, minus 100, 700, 1500. And the probabilities associated to X will be the probability associated to Hx. Okay, so the expected value of Hx will be equal to minus 900 multiplied by 0.1 plus minus 100 multiplied by 0.2 plus 700 multiplied by 0.3 plus 1500 multiplied by 0.4. And hence what you get, after solving this, you will get $700 as the net profit. Okay. There's a very important rule that comes out from here. So the rule that comes out from here, what we have just figured out, we figured out expected value of Hx, where Hx was of the form ax plus b. Did you observe? It was 800x minus 900. In the previous one also, it was something of that sort. It was 10x minus 40. So what we have just seen is that what we did, we had x, we figured out ax plus b, and with the probabilities attached, we could easily find out with a new probability distribution, we figured out our expected value in the usual way. Is there a shortcut to it? Yes, absolutely there is. Whenever your new random variable is a linear function of your original random variable, always remember expected value of a linear function is simply the linear function at the expected value. What I'm trying to say is that your linear function is ax plus b. So if you're interested in finding the expected value of this linear function ax plus b, it is just the linear function taken at the expected value. Now, why will this happen is something that you can test yourself by taking any one of the examples that we have done before and applying this there. And of course, out here, I can help you out with a proof. So expected value of ax plus b. turns out to be a times expected value of x plus b. Now, why and how this happens, let me just tell you. So consider expected value of ax plus b. Now, this means we are interested in the summation over all the x's of ax plus b multiplied by the probability attached to every x. So here, if you open this up, this is just a product. If you open this up, you get a x into px plus b times px summed over all the x's. So observe that this summation, just take it inside. You can break it up and you have ax into px plus summation b times px. Summation ax px, a is a scalar value which can come out. So a times summation x into px plus b is a scalar that comes out. It's not dependent on x, right? So whatever is dependent on x, you can write down here inside the summation. So what you get here is a times summation x into px. What is x into px? Summation over all the x's. It's the expected value of x, nothing else. Plus b times, what is summation px summed over all x's? The probabilities sum over all x's, that is the entire domain. The total probability has to be 1, right? So b into 1. So therefore what you get is a times expected value of x plus b, and that's what I started off with, right? I started off with claiming that expected value of a linear function ax plus b is nothing but the linear function at the expected value of x. So what we have used here are two rules. This proof, you can bifurcate it into two rules. Rule number 1, that in case you are trying to find out the expected value of ax, a times x. Expected value of a times x is nothing but a times expected value of x. And another rule, expected value of x plus b. Expected value of a random variable x plus b. B is a scalar. This is nothing but expected value of x plus b. When you combine both the things, you will get this result. So either which ways, whether you take down this proof and understand it through that, or else you just take rule number 1, rule number 2, combine the two, you will get the same result. This is what I wanted to discuss today. Thank you very much. I hope this will really help you in understanding the deep-rooted intuition with respect to expected value of a function. Thank you very much.